after everything, right? So let us start. Then we continue, right? Did you try the homework? Abid?
Yes, sir, I did, but I'm not sure with the answers.
No problem. If you are not sure, that's not the problem. You tried. That's the most important thing. Okay.
Yes, sir.
We said you to try, right?
Yes, sir.
Trying means to go forward, right? So till 1B we did. 1A and 1B we did last class. From today we will do from 1C, okay?
Yes, sir.
Can you read 1C please?
Figure 1.2 shows the screen of an oscilloscope. Before the switch is closed, the trace is a horizontal line across the middle of the screen, as shown in figure 1.2. When the switch is closed, the trace remains horizontal and moves up the screen.
Okay. When the switch S is closed, the trace remains horizontal and moves up the screen.
Yes.
Okay, then continue.
Component Z is heated. State and explain what is observed on the oscilloscope as the temperature of Z increases.
Yes. So what is component Z? Component Z is a thermistor, right?
Yes, sir.
So this thermistor is heated now. They are saying component Z is heated. Then if it is heated, what will happen to it? Resistance. Resistance is decreasing or increasing?
It will decrease.
Decrease, yes. If resistance decreases here, then what will happen to parallel combination resistance? Like 1.5 ohm and Z, these are parallel, right?
Yes, sir.
So if the resistance in Z decreases, then the combined resistance RP, that is called RP. So what will happen to that? Previously, you see, previously it has 6 ohm, right? Hello? Yeah, Abir. The resistance of Z decreases, right?
Yeah, sir.
And my
So
question
parallel
was,
combination will also decrease.
yeah, parallel combination also will decrease. And
Yes, sir.
if parallel combination is decreasing, then according to voltage divider rule, the
Voltage will increase.
voltage through the oscilloscope it will increase, right?
Yes, sir.
Voltage sharing through the oscilloscope it will increase. Then if voltage sharing is increased, that means the oscilloscope reading will be vertically, it will be more, right?
Yes, sir.
And it will
Move
move
upward.
up, right?
Yes,
Check in
sir.
the group, I wrote the answer. I gave the answer in the group, check.
Yes, sir. Yes, sir. Yes, sir.
Yeah, done.
Yes, sir.
So what you wrote?
As the temperature increases, resistance decreases. Therefore, combined resistance in parallel combination decreases. As a result, voltage sharing is more across 1.0 voltmeter. Hence, the horizontal trace moves more up.
Yes. So if it is going more up, that means the voltage reading is more, right?
Yes, sir.
So you got all 4 points for 4 marks.
Yes, sir.
Okay. Uh, his microphone is not working. Okay, now the next question. Read. Amir, read the next question.
Uh, the 12-volt battery is made from cells of electromotive force 1.5 volts, which are all in series. Calculate the number of 1.5 volt cells that make up the battery.
So calculate the number of 1.5 volt cells that can make up the battery, right?
Yes, sir.
So 12 divided by 1.5, how many?
8.
8. So write there 8. 12 divided and also show the working. Okay.
Hmm.
You see, I also sent it in the group.
Yes, sir.
Okay, so we are having 8. Then state the EMF of a battery made by connecting all of these cells in parallel.
1.5 volt.
What?
1.5 volt.
1.5 volt. If they are
Yes, sir.
connected in parallel, they
Yes,
will
sir.
remain same, right?
Yes,
Okay, now next question number 2, right? Okay,
yes, sir.
great.
The main part of a cathode ray oscilloscope consists of a glass tube. At one end of the glass tube, electrons are emitted by hot metal filament. State 2 requirements for there to be a continuous flow of electrons in the tube.
Okay, state two requirements for there to be a continuous flow of electrons in the tube. So these two conditions are written, right?
Yes.
You see here in our group I wrote cathode, uh, cathode or filament must remain hot to get supply of free electrons. Okay,
Yes, sir.
cathode in bracket you write filament must remain hot to get supply of free electrons.
And sir, the second point.
Second part, look, if we have hot filament, then we are having the free electrons, right?
Yes, sir.
And these free electrons need to be attracted with the positive potential, right?
Yes, sir.
So we should have high positive potential to accelerate free electrons, right?
Yes, sir.
So write that part.
Yes, sir. I wrote.
And it is also given in group. Did you see in group I gave?
Yes, sir.
Yeah,
I saw now.
yeah, it is also. And you see, gradually everything is given in the group. All the answers are given in the group. So can you read it, this part? B?
A microphone detects two pulses of sound. The output is displayed on the screen of an oscilloscope. Figure 2.1 shows the voltage output of the microphone varies with time. Describe how the time between the two pulses can be determined using the display on the screen of the oscilloscope.
Yes. So this one, once we discussed before, right? How we get the reading in the oscilloscope. That is, like in oscilloscope, we have squares, right? Small
Yes, sir.
squares. And from there we find peak to peak how many squares are there,
Yes,
isn't
sir.
it? So that one we are getting, for example, in between these two, you see in the group I wrote. Can you see what is written in the group?
Determine number of divisions between two peaks of the signal.
You see, I gave here 4.5 division, right? The
Yes, sir.
squares I showed you also. You got this worksheet printed.
No, sir.
Okay, look here. I gave the squares. According to that, from peak to peak, it comes 4.5 divisions, right?
Yes, sir.
So 4.5 divisions we are getting, and for each of the division, the time base is given 10 millisecond, right?
Yes, sir.
So that one I wrote time between two pulses
40 minutes.
45 millisecond,
Yes, sir.
right? You got it?
Yes, sir.
So this is our example. This is our example. Now the first one you see I wrote here determine number of divisions between two peaks of the signal.
Yes.
Then multiply the number of divisions with the time base setting on the of the oscilloscope.
Yes, sir.
So You understood it. The example given and the 2 points given are matching, right?
Yes, sir.
So we have to find the number of divisions, how many divisions between two peaks of the signal, and then multiply with the time-based number of divisions to get the time between these two peaks, okay?
Yes,
Two
sir.
pulses. Is it clear?
Yes, sir.
Then these two answers are done. Now, yeah, NAND gate. NAND gate you know, right? How to draw?
Yes, sir.
So draw it, NAND gate. NAND gate I also gave in the group. Are you seeing it? NAND gate?
Yes, sir. Yes.
Okay, do it there.
Yes, sir. I finished one.
Yeah, B, read B.
The two input terminals of a NAND gate are connected to zero voltage and no energy is supplied to these terminals. The output of the NAND gate is connected to an LED. The output is not zero and the LED is glowing brightly. Energy is applied to LED by NAND gate. State where the energy comes from.
So here we have, look,
From
the
the
output, yeah, the
from the
output of
battery,
the
the
NAND
energy.
gate is connected to an LED and it's working, right? LED
Yes,
is
sir.
working, though in the input, both the input terminals, we are having zero voltage. That means no energy supply in the input.
Yes,
However,
sir.
we are getting the LED is working. Why it's working? Because inside the NAND gate we have some power supply or battery, right?
Yes, sir.
Okay, from there it comes. So write it there in your answer line.
Yes, sir. I know.
Then they are saying you to complete the truth table for NAND gate. I gave you all the gates truth table, right?
Yes, sir.
So do it. Do
Sir,
it
it will
there.
be
Yeah,
1110.
yeah, 1110. Yes, very good. Very good. Thank you. Now, next one. Question number 3. Continue.
4.5 volt battery is connected in a circuit with an ammeter, a light dependent resistor, and it, 18, 1800 ohm fixed resistor. Figure 3.1 is the circuit diagram. The resistance of the LDR is 9000 ohm. Calculate the total resistance of the circuit.
Yes, so total resistance of the circuit, how you'll get it?
RP.
RP, you will get RP. So it is also done, right? There we calculated. You see the calculation, RP equals, you in our last class also we did a similar question, right? There we
Yes,
calculated
sir.
RP. Yeah, one RP equals R1, R2 divided by R1 plus R2, then 1500. Write it.
Yes, sir. I know.
Okay, then next one, huh?
Yes, sir.
Next one we are going the reading on the ammeter. Reading on the ammeter. Reading on the ammeter, we have to find with the formula V equals IR, right? It's
Yes, sir.
also
We have to
given in
find
the
I.
group, right?
Yes, sir.
Then we have to find I, current.
Yes, sir.
I equals V by R. What is your V? 4.5.
Yes.
And what is your resistance? 1500. Then calculate. Calculate it with your calculator. Then check
Uh,
what is the answer
0.03.
coming. Yeah, 0.003. Yeah, 0.003, or you can say 3 milliampere, right? 3
Yes,
into
sir.
10 to the power minus 3, whatever you write, same thing. Okay, then continue. Yeah,
Very bright lamp is switched on and the light intensity on the LDR increases. State and explain what happens to the current in the LDR.
yes. What is the current in the LDR? How will find it? Current in the LDR, state and explain what happens to the current in the LDR.
Current will increase.
Current will increase.
Yes, sir.
Why?
Because the LDR resistance of the LDR will decrease.
Yes, very good, very good. Then next one.
Uh, the current in the 1800 ohm resistor.
The current will be same, right?
Yes, sir.
Yeah, Karim, your second answer is wrong. It should be current remains same. Look
Sir,
at the
why will it
diagram.
change?
Here they are asking about 1800 ohm resistor, right? So for 1800 ohm resistor, you are getting the same voltage like before. You are getting the same voltage like before. For LDR, your resistance is changing. That's why your current is changing. But this resistor, the resistance remains same like before, and the voltage is also same because it is in parallel connection. Previously it was 4.5 volt, now it is also 4.5 volts. So current will also be same. Is it clear?
Yes, sir.
You understood it, Karim? Have you understood? No, no, not current divided same, Karim. You see here we have 18, 18 ohm, 1800 ohm, and the voltage is same. So you use the formula V equals IR. I equals V by R. If you check previous current and present current are same, but here LDR is changing as LDR's resistance is changed. Voltage is same like before in LDR, but the resistance is changed. That's why current in the LDR will be changed. Okay, is it clear, Karim? Okay. So we write here. Here we write. I wrote it in the group. Karim, see, it's written. A picture is sent. See, the second last picture I sent before your chat. That is, sir, can you enable chat in Zoom? That one, before that one, I gave the picture. You see, that one you write. The explanation is written there. You write in your worksheet. Current remains same. For this one, you will get marks, but in bracket, I wrote the explanation so that you understand it. Is it clear?
Yes, sir.
Is it clear to you? The explanation. Abir,
Yes, sir.
B2 is clear to you, right?
Yes,
Then
sir.
4. Question number 4. We are going.
In,
Yeah, continue.
in the engine compartment of a car, the battery supplies a current of 120 ampere to the starter motor. The starter motor is switched on for 3.5 seconds. Calculate the charge that passes through the starter motor in this time.
Yes.
420.
Yeah, Q equals IT, right?
Yes, sir. 120 into 3.5.
Yes, 420 coulomb, right?
Yes, sir.
So next one you read.
The starter motor circuit is switched on and off using a relay. The relay is controlled using a second circuit. Switch in the second circuit is used by the driver to operate the relay and turn the starter motor on and off. Explain how the current in the second circuit controls the relay.
Yeah, here we got 2 marks, right?
Yes, sir.
So for 2 marks, you have to write that about the idea of electromagnet, right? We use an electromagnet, so when current flows in second means the smaller circuit, that one is DC circuit. It turns on the starter motor circuit. That means when the electromagnet is attracting the switch of the starter motor circuit, then starter motor is on, right?
Yes, sir.
Is it clear? We got one of the yeah, we got one diagram in our notes, right, about relay.
Yes, sir.
You can remember that one, isn't it?
Yes, sir.
So that one is clearly showing you how the relay works. So write this one. I wrote in the group, check. We use an electromagnet, so when current flows in second circuit, that is smaller circuit, it turns on the starter motor circuit, and current is off in second circuit, starter motor is off. Yeah, Karim, you should bring the idea of electromagnet. Electromagnet idea, to bring it, you have 1 mark. Here, 2 marks. Is it clear? What you wrote for that one, you will get only 1 mark. You check what I wrote in the group. That one you take. Okay, so our this worksheet is done, right? Or we have another
Yes, sir.
question left. Yeah, another question is left. Okay, then continue. Continue, please.
In a cathode ray oscilloscope, a beam of electrons is produced by a filament one end, at one end of an evacuated glass tube. The electrons are then accelerated and strike a state at the other end of the tube. Describe how the electrons are produced by a filament and how they are accelerated.
Okay. Yes, yes, type it, type it. Type it. Already we got idea, right? In our last question, we got that by heating we are having free electrons, right?
Yes, sir.
And we have the high positive potential in the other side. That's why this is accelerated, right? Isn't it? We got that idea. Now, other point you have to mention here. He is writing. Let us see what he is writing. Karim, write at least first part, then write another part. Hmm. So are you seeing the answers?
Yes, sir.
Yeah, you write thermionic emission from hot filament lamp, the high potential difference setup, and electrons are attracted by anode. Okay, you write Karim. Better to write high positive potential. Huh? Other than writing potential difference, if you are writing positive potential, that is more appropriate. Okay, because electrons are attracted there. The answer is also given in the group. You can check it there. Then the next one. Yeah, next one. Continue. If you are done with writing, Amir, you do the next one. Read.
Explain why the glass tube is evacuated.
If the glass tube is not evacuated, evacuation means it's vacuum, right? So
Yes, sir.
if there is not vacuum, then electrons movement will be hampered, right?
Yes, sir.
Electrons will ionize the air, it will slow down, right? Isn't it? That's why we should make it vacuum. Look here, the answer I wrote. So that electrons are not colliding with the air molecules and they then can move easily towards the screen.
Yes, sir.
Is it clear?
Yes, sir.
Yes, very good, very good. Yeah, Karim, it is correct. Your answer is also correct. Then next one, see,
The
read.
expression booklet for a who states that strong magnet must be Please close to that. Explain why a strong magnet close to the ore deflects the electron beam.
Yeah, if there is a strong magnet close to the CRO, then electron beams, electron beams are negatively charged, right?
Yes, sir.
And the flow of electrons is opposite of current flow, right? Current flow direction. So if you are thinking of Fleming's left hand rule, then current direction, then magnetic field, you must have the force, right? So because
Yes,
of
sir.
this force, the the electrons will be deflected, right?
Yes, sir.
That's why it's not wise to bring strong magnets closer to CRO. So you see the explanation I wrote. Flow of electrons represents the conventional current flow in opposite direction, which creates a force in magnetic field according to Fleming's left-hand rule. That's why we get deflection. Is it clear?
Yes, sir.
Yes, correct, correct, correct. Karim, it is also correct. Your answer is also correct. So we are done with the worksheet. Now you have any questions, you can ask me on this topic. You have any questions? So if you don't have any questions, you get ready for a test. Can you take the test now? Yes, Karim, can you take the test now? Yes. What about Abir? Abir,
Uh, Sir, I need some revision.
you need revision. Okay. How long you need to revise?
Half an hour.
Half an hour you need. So after half an hour you can take the test, right?
Yes, sir.
Okay, no problem. Then after half an hour you take the test. Then Karim, you are ready for the test, right? Hello? Or you need also half an hour? Karim? Hello? You are ready. Okay. So I am sending you at 10 o'clock, Karim. And okay. Okay. So I am giving you after 10 minutes, and uh, for Abir Khairul, it is after half an hour, that is 10:20. Okay. Okay, 10:20 you will get your script. Thank you so much for joining. Okay, Allah Hafiz.
Salam.
Wa salam.